Okay, so let's try to make AES run on intermittent power supply. In order to do that, we would need some kind of a checkpoint and restore facility. This is done by two custom defined functions in my program, restore and checkpoint. So the restore function is called every time execution starts from the beginning. So it would be called every time a power cycle occurs, and as a proof of concept, I checkpoint the state every 256 rounds. So let's see what these functions do. The restore function checks for a flag in memory. If this flag is not set, that means there is no valid checkpoint in memory. The round counter value is set to 1 and the LED 0 is turned on. This signifies start of the program from the beginning. If the checkpoint flag is set, which means that a valid checkpoint is present in memory, it would restore the state, that is, it would restore the round counter and the plain text value at that point, and it would then turn on LED 0 as well as LED 2, signifying that execution is continuing from checkpointed state. And this is the checkpoint function. So what it does is basically checkpoints the round counter value and the plain text value and sets a flag in memory. It resets this flag once the execution completes. This is done for testing purposes, so that once execution is complete, if we press system reset, we can again test the code, validity of the code again. Finally, once the program completes execution, an LED number 2 should turn on. So at the end of the code execution, LED 0, LED 1 and LED 2 should all turn on together, and this would signify the end of the program. So let's see this in action. Okay, so as we can see, one LED turns on, which means the program has started, and when it completes, the LED number 3 should turn on. Since there were no power cycles, LED number 2 did not turn on because we did not have to restore state from a checkpointed state. However, if a power cycle occurs, the first and the second, both of these LEDs should turn on. Now I have configured my program in a way so that once it completes execution, if I press system reset, it should start from a fresh state. As you can see, one LED turns on, program has started execution. Two LEDs, it has restored state from checkpointed state. You can see it did not revert back to one LED, so program continues, it doesn't roll back, and as you can see, the program completes execution. See all of this once again. Power cycle, another power cycle, it did not roll back to its original state, and completes execution. When I try to recreate the same on intermittent power supply, I face some issues. I'll show you what those issues are. As soon as I connect this board to intermittent power supply, this LED 0 flashes. This signifies that the program is starting. However, it does not continue flashing after that, which means that no execution is happening on this board, as you will see now. As you can see, LED 0 flashes, which meant that the program started execution. However, it's not flashing anymore. This could be happening because of two reasons. First, there aren't enough number of checkpoints to continue execution of the program. However, if that were true, at least the LED 0 should have kept on blinking, because the program would have kept on restarting. However, since LED 0 is not doing that, it means that the program is not even running. So this could be because of another issue, that maybe the board is not properly connected to the power supply. However, if that were true, this LED 0 should not have flashed in the first place. And so currently, as it stands, my prognosis is that the reasons of these issues are inconclusive.